Hello everyone, welcome to another one of my Leetcode videos. In this one we'll do Leetcode number 2, which is add two numbers. So basically we're given two linked lists that represent numbers and we need to return their sum as another linked list. So I won't walk through this example, I'll just go through some example over here and then explain the input and output as I go through that. So let's say you have two numbers. In this case the two numbers are actually 342 and 465 because the numbers are actually given to us in reverse. So basically the linked list head is at the ones place and it's going backward, right? So it's 2 4 3, that's what we see here, and then 5 6 4, that's what we see here. So when we sum up two numbers, what we do is usually we start from the ones place. So we'll be starting from the head of the linked list and we write 7 because 2 plus 5 is 7. And then we go to the next place. We have 4 and 6. We carry 1, right? And we write 0 in the sum. And then we sum up 1 plus 3 plus 4. So that is equal to 8. And that's 807. So again, the output is also returned in the same way. So we start from the 1 place as our head. So we have 7, 0, and 8. One thing to note here is that the sizes of these two might not be the same, right? So we could have, for example, a linked list that's like 34 plus, let's say, 129, right? So in this case, when we add the two together, we have 9 plus 4, that's 13. And, completing the remaining, we have, we carry 1 from the 13, add these two, and add this. So we get 163. So we have to keep going until both lists are empty, and just keep track of a carry digit, right? Because at each addition we might have to carry something and add it on to the next round. So we'll keep track of our carry, and then we'll just sum these two to create a new linked list, and we'll keep going until both linked lists finish, because we need to go all the way till the end. And if one linked list finishes before the other, we'll just default that value to 0, right? So that we can write the entire logic consistently. So let's go into the code, and then hopefully you'll see a bit more clearly how this works. So again, our terminal condition will be both of the lists getting empty. So we'll say while not L1 equal to null and L2 equal to null, because we need both of them to be null, right? So while that's not the case, we'll go ahead and add the numbers. So we'll have the digits. So here I've gone ahead and grabbed the two digits. So if L1 is null, that means like if we already reached the end, we'll just default it to 0 as we showed earlier. Otherwise we'll pick the value, and same for L2. And before I write the next thing, at the end of the loop, we just want to advance our L1 and L2, right? So I'll just go ahead and do that. But remember, we only need to advance it if it's not null, because otherwise we'll get a null pointer exception, right? So we'll just go ahead and put those conditions. So I've gone ahead and put both of those conditions. Remember, one can reach the null before the other, so that's why these are important to put in place, just to make sure that we don't get null pointers when we do .next. So now we also need to keep track of our result list. So we'll first keep track of our result list head, right? So this will be set to the first node, and because that's what we'll end up returning, right? So we'll end up returning our result list head, but we also need to keep track of result list last node, because every time we compute a new value, we need to add it to the next of the previous node. So we'll need to keep track of both the last node and the head. The last node is for adding the next value onto, and the head is for returning at the end. And finally, we also need to keep track of our carry, because as we add digits, we might need to carry something on to the next round, right? So here, let's compute our sum. So our sum will be equal to digit 1 plus digit 2 plus our carry. Now that we have our sum, our new digit will be equal to sum modulo 10, right? Because we only want to keep one digit and then carry over the next, right? And then our new carry will be equal to our sum over 10, right? So that will be just the, the tens place of the sum, right? So for example, if the sum is 18, the sum mod 10 will be 8, so we keep 8, and sum over 10 will be 1, so we carry 1 to sum on to the next place, right? So that's our sum and carry, and now we should just create our new list node. So we create our new node is equal to new list node of new digit. So we put our new digit in our new node, and now we just have to add our new node to our list. So if our head is equal to null, that means that this is the first node, then we just set the head equals to the new node, right? Otherwise, if it's not the first node, what we'll do is we'll pick the last node and set its next equal to the new node, right? So the next node of the last node will be the new node, so that's how the new node is added to the list. And at the end, we'll set our last node equal to our new node. So in both cases, we want to update our last node pointer to point to our new node, right? And at the end, we return our head. So I believe this should do it. Let's try to run the code. So we missed one case here, because at the end, if we look at this, our carry could still be 1, right? Because even if after we add the last two nodes in the list, we could still have a remaining carry. So we just need to do one operation at the end saying if carry is not 0, so that means if we still have a non-zero carry, then we need to create a new node with that carry digit and add it onto our list. So we should say that our last node dot next is equal to carry, and that will add the carry if it's not 0 at the end of the list. And so let's run that and see now if that works. Oops, they should be new node, not carry, because the carry is inside here. Okay, now it's accepted. Let's submit. Perfect. Thank you so much for watching. I'll see you in the next video. Cheers.